Good morning, guys. Welcome back to another video. In the last video, we talked about right triangles, things you can do with right triangles, different things with angles, sectors, radians, degrees, those kinds of things. So we're kind of progressing along. One of the things that shows up quite a bit in pre-calculus is solving things with triangles that are not right triangles. So now you know how to solve right triangles. In this section, you solve oblique triangles. Now, listen, a lot of you guys know what right triangles are. Oblique triangles are triangles that have no right angles. Obviously, right triangles are triangles with right angles. So oblique triangles have no right angles. And in standard notation, the angles of a triangle are labeled capital A, B, and C. And the opposite sides are labeled lowercase a, b, and c, as shown. So right here we have a perfect example of an oblique triangle. We notice that there are no right angles. Here we have angle A, and across from angle A, opposite of it, is side A. We have angle B, uppercase B, and across opposite of angle B is side B. And then of course we have capital angle C, which across from it, lowercase side C. So this would be an oblique triangle, and this is going to be the standard notation. Capital letters for all the angles, and then lowercase letters for the sides that are opposite of those angles. So to solve an oblique triangle, you must have these situations. Number one, you could have two angles in any side. So if you're familiar or you remember back in geometry, you had AAS, which was angle, angle, side, and you had ASA, which was angle, side, angle. If you have any of those two situations, that would be okay for solving an oblique triangle. You could also have two sides and an angle opposite one of them. So in this case, SSA, so it would be side, side, angle. Notice how conveniently we didn't put it the other way. I'll leave you to that. How about number three? You could have three sides. So if you have side, 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 then you can use the law of sines to solve the oblique triangle. So again, that's just having all the sides. So in this case, if you had lowercase a, b, and c, you would be able to solve the triangle. And last but not least, if you have two sides and they're included angles, so if you have side, angle, side, which is one of the most popular ones that you would have seen in geometry, you could also solve the triangle. So at this time, I should say, when you solve a triangle generically, you find all of its sides and all of its angles. That means you have three angles and you have three sides. So in order to solve a generic oblique triangle like this one, you would have to find out what is capital A, B, and C, and what is lowercase a, b, and c. So now let's get to it. The major point of today, which is the law of sines. The law of sines is kind of a simple one once you understand it, but it's really nice because it helps you solve triangles that are not right triangles, which now most of you are very familiar with. So what does it say? The law of sines says if you have ABC, so if you have angles ABC, and it's a triangle that has sides A, B, and C, then there exists a ratio between the sine of those angles and their side length. So notice here I have A over the sine of A is equal to B over the sine of angle B is equal to C over the sine of angle C. Now notice it's a relationship between all of the sides and the sines of all the angles, but you don't have to have two equations and three things equal to each other. It could just be the case that you start here, where A over sine of angle A is equal to B over sine of angle B. So that's one way to do it. Another way that you could write it is just flip-flop the numerators and denominators. You could notice the similarities here. If I just do the reciprocal, I'll have sine of angle A over side A is equal to sine of angle B over side B is equal to sine of angle C over side C. I always grew up doing this one, so I'm just going to write it in this notation, but it'd be no different if you wrote it this way. You'll see why here in a little bit. That's regardless of which way you write it, it's going to come out correct, but I'm going to use this one right here because that's what I've done since I learned it. Okay, so that's the major idea. And then knowing this law of sines, this relationship that exists between the sides and the sine of all the angles, you can solve the triangles. And like we know, solving a triangle is finding all of the sides and finding all of the angles. Okay guys, so let's see what happens. So how about example one? I'll leave that there so we can see it. In example one, it says for this triangle below, notice that angle C is 102 degrees, angle B is 29 degrees, and side B is 28 feet. Find the remaining sides and the angles, otherwise known as solve the triangle. So if you wanted to write on the notes, this means the same thing as solve the triangle. So if you see that kind of direction, find all the angles, find all the sides. Okay, so the first thing I should do is maybe find out what situation I'm in. So here I have an angle then I have a side, and then I have an angle. So in this case, I am an angle, side, angle. And if I go back to the top of my paper, that fits the first situation. Angle, side, angle means that I can solve it. So I probably should. What could be the easiest place to start with? Well, we're looking for all the sides and looking for all the angles. So I notice I have two of the angles. It could be a very easy start just to find the missing angle that's here. So can I find the missing angle A? Well, if I know that C is 102 degrees and B is 29 degrees, then what do I know for sure about A? Well, I know that there's 180 degrees inside of a triangle. So if I take 102 and I add it to 29, it's 131. How can I find out what angle A is? I can take 180, I can subtract 131. What will be left over is 49. So knowing that, I could write it already. I could say that angle A is going to be 49 degrees. If you want, you could even label your picture, 49 degrees. I now have all the angles. So to finish solving for the triangle, I just have to find the missing sides. And here's where the law of sines comes in handy. So one thing I do know in terms of sides is I know that side B across from angle B is 28 feet. I don't know side A, which is across from angle A. I don't know side C, which is across from angle C. So the first thing I should exploit is the fact that I know side B and I know angle B. So the first thing that I would write with the law of sines would be B, the side length, which is 28, over sine of the angle that's opposite of it. So in this case, sine of B. So side 28 feet is across from 29 degrees. So I'll do sine of 29 degrees like this. Equals, now what will be the first side length that I want to solve for? Well, how about we solve for A, right? So if I don't know what side A is, I can incorporate that as my variable, so lowercase a there. And I know that's going to be divided by sine of the angle opposite of it, which is 49, which is why I just found that angle earlier. So now notice I have kind of a proportion. I have two fractions that are equal to each other. So what would I be allowed to do if I have two fractions that are equal to each other? Well, I could cross multiply. So if I multiply this way, I'm going to get A times sine of 29 equals, if I go this way, 28 times the sine of 49. All right, how could I get A by itself? Well, I see A times the sine of 29. I can divide by sine of 29 on both sides. And I know that A, and I can say approximately, is going to be equal to 28 times sine of 49 all over sine of 29. And then just to make sure my calculator doesn't freak out when I input this, I'll put an extra set of parentheses around the top or the numerator. So let's go to the calculator. First things first, on your calculator, just make sure you're in the right mode. So right next to the second button on mode, hit mode, and then just make sure that you're in degrees. So again, we're here, degrees. Notice the other option is radians, but since all my triangles have degrees, I know I'm doing everything with degrees. So make sure you're in degrees. If your calculator is showing radians like this, then just go over once to degree, hit enter, and then it should highlight degrees. Okay, second mode, so hit seconds and mode. That will get you back to the home screen. And now we can start doing our calculations. So what did we say? Open up a parenthesis, 28 times the sine of 49, and then divided by sine of 29. So something like this is what the calculator should look like. Hit enter. 43.588. So 43.588. 43.588. Okay, so I have three angles. I have two sides. The last thing I need is that last missing side. So what's the last missing side that I don't know? I don't know C. So what I can do is I can set up something very similar. I'll have to go again. So this is my first iteration of the law of sines. I can take the law of sines and use it one more time. Again, I know that side B was 28 feet across from 29 degrees, so 28 over sine of 29 equals, but now in this case I want to solve for C. So what should I write on this side of the equation? Well, I should write lowercase c, which I don't know, all over sine of the angle opposite of it, which is 102. So let's go sine of 102. Well, I have a proportion. I have two fractions that are equal to each other. So I'll be allowed to cross multiply. If I cross multiply, very similar to what we did in the first one, I would have C times the sine of 29 equals 28 times the sine of 102. All right, get C by itself. I see multiplication, so I will use division, very similar to what we did in the first one. And I would have something like this. C is approximately 28 times sine of 102, all over sine of 29. Again, I use an extra set of parentheses on the top there just so the calculator doesn't freak out. I'll type it in with you just to make sure we have it. All right, so let's go parenthesis 28 times sine of 102 divided by sine of 29. All right, hit enter. 56.493. So 56.493. All right, now at that point, have we solved the triangle? Well, yes, we have all three angles, and now we have all three sides. Notice we had B from the beginning, we solved for A and we solved for C, so we are in business. All right, guys, so there's a really good example of how you can do this using the law of sines. Okay, let's go example 2. So example 2, in a very similar fashion, now that we have the idea, gives us a picture of a roadway, and then there's going to be either a light pole or a telephone pole. And notice that this telephone pole is on a little bit of an angle. So a couple things to note in the picture right away is that normally we'd have a 90 degree, but notice that this pole is an obtuse angle. It's more than 90 degrees, and it tells us it's 8 degrees more. So then right here for angle A, I have 43, but then how about for angle B? If I know that it's obtuse and it's an 8 degree more tilt than 90 degree, then what would be the degree measure for angle B? Well, the degree measure for angle B would have to be 98 degrees. All right, let's see the situation. A pole tilts towards the sun at 8 degree angle from the vertical, which we just addressed, and it casts a 22-foot shadow on the ground. So in this case, this side is the shadow. The angle of elevation from the tip of the shadow to the pole is 43 degrees. We know the angle of elevation is one that's where you're looking upwards. So we can see from the picture this 43 degrees is from the horizontal up towards the top of the pole. How tall is the pole? So in this case on the picture, A. So we have this side A, that looks like it's going to be the length of the pole. That's going to be what we're solving for. So the first question is, do I need to solve this triangle entirely? Do I need to find all the angles and all the sides? Well, no, they're just asking for side A, so I don't need to do all that work. But one thing that could definitely help is knowing the angles. So angles are not terribly hard to solve for, especially if you have 2 out of the 3. You can get all 3 of them pretty quickly. So I suggest doing that. So how about here? I know that angle A is 43 and angle B is 98. So then what has to be angle C? Well, very similar to what we did in the last one. You could add up 43 and 98, which is 141. You could subtract that from 180, and you'd find out that it's 39. So if you wanted to, you could set up something like this. All right. Now, if I want to solve for side A using the law of sines, how could I do it? Well, which sides and which angle would have to be included? Well, I don't know anything about side A. I don't know anything about side B currently, but I do know that side C is 22, and I do know that angle C is 39. So if I know that side C is 22 and angle C is 39, then I have to use that in my law of sines. I need to have at least 3 knowns and 1 unknown in order to solve. If I have more than 1 unknown, then it's going to be very hard to solve for the unknown. So in this case, side C is 22, all over sine of the angle opposite, which in this case, angle C was 39, equals, now I want to solve for side A, so I have little a, all over sine of 43. You see? So that's why it was so important knowing what angle C was, because if I didn't, I would have sine of C right here, and then I would have 2 unknowns to solve for, which wouldn't work, right? When I set up my proportion, I want to make sure that there's just 1 unknown, and the rest of the other 3 things are known. So then how can I solve it? Well, I have a proportion, so of course you're allowed to cross multiply. So do we get this way? We'd have 22 sine of 43 equals A times sine of 39. I see A times sine 39, so I'll divide by sine of 39, divide by sine of 39. I know that I should probably put in extra parentheses. I'll use brackets this time. So then what can you tell me about A? It's approximately, let's punch it in the calculator. So here I go, parentheses, which in this case will serve the same as brackets, 22 times sine of 43 divided by sine of 39. All right, guys, something like 23.842. 23.842. Let's round to 3 decimal places. Now, what are the units? Is this Cheeto Puffs, kick flips, Eclipse gums? What is this going to be, right? So in this case, if we're looking at A, we know it's the side length. We know the side lengths are in feet. So in this case, it's going to be 23.842 feet, approximately, because we are doing some rounding. It's not exact, but it's pretty darn close. All right, guys, that'll do it. So example 2, you don't always have to solve the entire triangle. Most of the times, just like these word problems that we've seen with the right triangles and as of late for the assignments, you can also do quick word problems using the law of sines. Again, what makes it so beneficial and what's so helpful about it is that it's for non-right triangles. Most of you guys are bosses when it comes to right triangles, but for non-right triangles, you can use this relationship that exists between the sides in the angle of, or in the law of sines. Okay, so we have a couple more quick examples, and then we'll call it and give you some to try on your own. So it talks about an ambiguous case. The ambiguous case is the side-side angle. Again, the running joke with geometry, even though I don't teach geometry, I didn't teach you geometry, is that we always say side-side angle and not the other way around. I'll leave it to you to figure out why. In the first 2 examples, you saw that 2 angles and 1 side determine a unique triangle. However, if 2 sides and 1 opposite angle are given, 3 possible situations occur. No such triangle exists, 1 such triangle exists, or 2 distinct triangles may satisfy the conditions. So what makes SSA, or side-side angle, ambiguous? Well, it makes it ambiguous because there could be no triangles to solve, there could be 1 triangle to solve, or there could be 2 triangles to solve. So in this case, what makes it ambiguous is there's not just 1 triangle to solve. The ambiguity is how many triangles are you solving, 0, 1, or 2. So there are some things that arise from there. So if you want, you can take a look at this little ambiguous case. It gives you some nice ideas as to how you would know. But I think that there's a very natural way to know if something's ambiguous, if you'll be able to solve it or not solve it. So there's not much you need to memorize from this table, especially since you probably won't see it after we talk about it here until next year. You might forget something like this. Let's just look at the examples, and I think that'll be a very natural way to determine if the triangle is solvable or not. So let's go to example 3. So in example 3, it says, find the remaining sides and angles for this triangle. So what do you think? Would it be easy to do right away? Well, notice I have angle A and I have side A. I have side B, but I don't know angle C, I don't know angle B, and I don't know side C. So I can't really say anything currently about the angles. I can't really say anything currently about the sides. Could I do Pythagorean theorem? Could I say 12 squared plus 22 squared is equal to C squared? Well, no, I can't use Pythagorean theorem because, again, we're not in right triangles anymore. We're talking about oblique triangles. So in this case, Pythagorean theorem is only for right triangles. So the only thing that's going to get me out of it is the law of sines. So which one of these pieces of information must I start with? Well, I definitely need to start with this. I know that side A is 22 and angle A is 42, so that has to be included in my calculations. So I would say 22, the side A, all over sine of the angle A, which is 42, equals, which one should we start with? Well, which one do we have to start with? Do we have to start with C or do we have to start with B? Well, if I do C, then out here I'm going to have side C, lowercase c, over sine of C, 2 unknowns. But if I go with B, then I know little b is 12, all over sine of capital B, which is the angle. And now notice there's just 1 unknown, and now I would be able to solve for it. So again, how could I do it? Well, I could cross multiply. If I cross multiply, then here I'm going to get 12 sine of 42 equals, I'll cross multiply this way, 22 times sine of B. Get sine of B by itself, I'll divide by 22. So I'll divide both sides by 22. So then what will this one look like? Well, I have to go into the calculator like we did the last one. Let's throw parentheses around the top of this, an extra set. So now we'll go parentheses 12 times the sine of 42 divided by 22. So with the rounding, 0.365. So we have sine of B is 0.365 Now this is a good question. How can I solve for b? Can I just divide both sides by sine? Well, no, this is sine of b. So what will be the only way to get to b, to solve for it? Well, hopefully from the last couple videos, you caught on to the idea of the inverse. So we can go inverse sine of both sides. I'll inverse sine the left. I'll take the inverse sine of the other side as well. So something like this. The inverse and sine will cancel, leaving you with just b. In this case, approximately. Let's go into the calculator. How do you get inverse sine? Well, you hit second. Then you hit sine. That's going to give you the inverse. And then 0.365. If you do this, you get 21.408. 21.408. And then this is an angle. So that means that this is going to be in degrees. So we have angle B. Well, what would be the next easiest thing to come up with? Well, the next easiest thing to come up with, I would hope, would be angle C, right? So if A is 42 degrees and B is 21.408 degrees, then you can add them together, right? 0.408. You can subtract them from 180. And you get something like 116.592 degrees. So then C, you could say, approximately 116.592 degrees. Okay, so now I have all the angles. I have side A, and I have side B. The last thing I need to do is find side of C. So then how could I do it? Well, I know now that this is 116.592. I know that this is now 21.408. So if I was you, I'd start off with the one known that I had from the beginning, which was this relationship between the side A and angle A. So I'll try to sneak it right here. So that would be 22 over sine of 42 equals side C, which is the unknown, over sine of 116.592. I have a proportion, so here comes the cross multiplying, this way and this way. I'll sneak it right here. C times the sine of 42 equals 22. Sorry, I'm going to run out of space. Sine 116.592. I have C times the sine of 42, so divide both sides by the sine of 42. So I'll divide this side by sine of 42 as well. Those will cancel. And what do I know about C? Well, it's going to be 22, sine of this 116.592. So extra set of parentheses, guys. Parenthesis 22 times sine 116.592 divided by sine of 42. Punch in the calculator, 29.400. All right, so we have 29.400. And now it's a little lowercase c, so it's not degree. So that means that this is the side length. So did I find the remaining sides and angles? I sure did. I found all the angles. I have all the sides. 6 things total. That's what it means to solve the triangle. So in this case, the ambiguous case was just for one triangle, and it looks like it worked out. Okay, so if you're good with that, then let's keep rolling. So how about for example 4? Here it says we have another ambiguous case. Show that there is no triangle for which A equals 15, B equals 25, and A equals 85. Well, let's just play the hypothetical. One really nice way to prove that something does not exist in math is to hypothetically assume that it does. So if I want to show there is no triangle for which these things would be true, then let's assume that they are true. Let's say we have a side of 15 for A, we have side B of 25, and we have angle A is 85 degrees. So if I have side A and angle A, the first thing I would set up would be 15 over sine of A, which is sine of 85, equals, now I have something with B, it's side B, so 25 over sine of angle B, which is lowercase or uppercase, so something like this. I have a proportion, so I can cross multiply. The first one I have, like we've been doing, 25 times sine of 85 equals 15 times sine of B. Get sine of B by itself, so divide both sides by 15. So then here I have sine of B equals, let's go into the calculator, extra set of parentheses. So here we go, parenthesis, 25 times sine of 85, right? and then we'll divide it by 15. So I get 1.660. So 1.660. Okay. Now I want to solve for b. Notice here I have sine of b. So how could I do it? Well, I can take an inverse of both sides. So inverse this side on the left, inverse the right, and let's see what happens. So then I notice these guys cancel. And then let's see, I can sneak b here. Let's go in the calculator. So I'll clear off. Let's hit second. And then sine. That gives me the inverse sine. And 1.660. And if I punch it in, error domain. And it tells me there's a problem. So there's a problem with the domain, which means 1.660 is the thing that you're putting in. That's the domain. It's not in the domain of inverse sine. So in this case, you would have to say that this question is not possible to solve by the law of sines. So is there something else that you could use to solve something like this? I guess that's the motivating question. And I guess we'll see. I don't want to spoil it, but we'll go from here. So in this case, I can't solve example 4 using the law of sines. Maybe there's something else coming in the upcoming days that will allow us to solve that. Okay, so that's what I mean by not having to memorize this ambiguous case idea. If you're naturally solving and you run into a problem where you get an error in the calculator, then you know it's not possible. All right, guys, last one. So last question here. It says, we have an application, of course. The course, no pun intended, the course for a boat race starts at point A and proceeds southwest 52 degrees to point B, and then in the direction of southeast 40 degrees to point C, and then finally back to point A. Point C lies 8 kilometers directly south of point A. Approximate the total distance of the race course. All right, guys, so we're starting at A, this race. It's going to point B, then it's going to C, and then it's coming back to A. So that would be 1 lap in the race, and that's what we're trying to find. So if I wanted to approximate the total distance of this race, I would have to know how big this is, AB, which is across from angle C, so maybe I should label it little c. I have to know what's across from angle A, so we'll call that lowercase a. And then across from angle B, I do know is 8 kilometers from what they gave me in the picture. Also in the setup of the question, this is side little b. So if I can solve the triangle sides, then I just have to add them up, and that would be how long the race is in terms of distance. So I have 52 degrees for A. Naturally, the first place that I think it's easier to start with is to try to solve for the angles. But notice here I have 40 degrees, but the 40 degrees is not for angle B. It's 40 degrees off of angle B. So how could I manipulate this picture to try to solve for angle C and solve for angle B? I also know that point C is directly south of angle A. So one kind of a sneaky way to do it, maybe I'll use a pencil for this, is to draw this line across, because now I know that this is going to be 90 degrees, and then I know that this is going to be 90 degrees. So then if I'm looking at this triangle right here, if this is 40 and this is 90, how big does this have to be? Well, it has to be 50. Now I know that these two angles make up a right angle. They're complementary. So if they're complementary, then if this is 50, what does this have to be? It has to be 40. So in this case, I know that angle C, so if I wanted to write it here, angle C is 40 degrees. All right, and you can also use the fact that if these two things are parallel to each other, these could be like alternate interior angles, if you like it like that, or if you remember that kind of a terminology, then that's also true. Well, now I know that if this is 52, and if this is 40, then what does angle B have to be? Well, if this is 52 and that's 40, that's 92 together. Subtract from 180, that would mean that angle B has to be 88 degrees. So maybe I'll put it here just so that I don't muddy up the picture anymore. So I have the angles, right? I have A, I have B, and I have C. So which fact must I start with? What has to be in all my calculations? Well, I know angle B is 88 degrees, and I know that side B is 8 kilometers, right? I don't know anything about side C or side A, so I have to use B in my calculation. So the side length for B is 8 all over sine of angle B, which we know is 88 degrees, equals, what side should we solve for first? Well, why not C, right? That's where the race starts at A and then goes to B, so let's find out what side C is and go from there. So I can say side C over sine across from C. The angle is 40. So let's set it up like this, right? All right, proportion means cross multiply. So C times the sine of 88 equals 8 times the sine of 40. Get C by itself, so I'll divide both sides by sine of 88. Of course, extra parentheses so the calculator doesn't freak out. I'll use brackets so they look different than the parentheses there. Let's see, we have C, no pun intended, is approximately, let's go in the calculator, right? So parenthesis 8 times sine of 40, parenthesis, divided by sine of 88. And in this case, we get something like 5.145. 5.145. All right, and that's going to be kilometers. We know that from the problem. We also know it from side B is in kilometers as well. All right, guys. So what's the last thing we need to find? Well, we know now side C. We know side B. We need to find side A. How should I start it? Maybe pause the video. Try to set it up for yourself before I do. Otherwise, I'll just dive right in. We'll use the same fact. We'll start with 8 over sine of 88 equals, but now I want to find side A over sine of that angle, which is 52. No surprises, proportion means to cross multiply. A times sine of 88 equals 8 times the sine of 52. Maybe I'll throw in extra brackets already. Divide both sides by sine of 88 to get A by itself. All right, and I got A is approximately, we'll go into the calculator one more time, parenthesis 8 times sine of 52 divided by sine of 88, 6.308. 6.308. And this will be in kilometers. So indirectly, I had to solve the triangle, right? I had to find all the angles and all the sides. But what's going to be the final answer? Well, if I want to find the total distance of the race course, I just have to add what is A plus B plus C in terms of lowercase. So last calculation, guys, let's take what we have, right? So let's take A, which is 6.308. We'll add it to B, which is 8, and we'll add it to C, which is 5.145. So altogether we have 19.453. 19.453, and this is all in kilometers. So our entire race is just the outside of this triangle. It's this right here. So it turns out this is the kind of calculations they actually use when they do water sports and other things where it's kind of hard to measure, right? If you were on a lake and you were going to try to do this kind of a race with a boats or jet skis or something, I mean, it's really hard to pull out a tape measure and measure with the waves and everything else going on as to what the distance would be. So you can actually do things with angles like this to determine what kind of angles you would need. It's much easier to measure angles on the water than it would be distance. Okay, so big things considered, something a little bit new, law of science. Helps you solve for triangles that are not right triangles, which we know not all angles in life are going to be, or not all triangles in life are going to be right triangles. So knowing how to solve oblique triangles is kind of an important skill. We know that it can't handle everything, the law of science, but maybe that's why there are some other things to come. All right, guys, thanks for watching the video again. If you can complete the assignment that's on Canvas, I would greatly appreciate it. Otherwise, I hope you have a great day, and hopefully the weekend is nice and the weather is satisfactory so you can get out there and you can do something and not just stay home the entire time. Have a good day, guys. Bye-bye.